Alright, here we're asked, we have a right triangle and it's defined as, anyway, a right triangle has a right angle in it, which means that two of the sides intersect perpendicularly. So what we have to do is figure out if that happens. So what we're going to do is find the slope between each of the 2 points. So let's go ahead and start here from A to B. So slope AB. Alright, so we know it's going to be y2. We'll go ahead and put the formula up here. So let's go y2 minus y1 over x2 minus x1. Okay, so here's what I'm going to subtract my y values. I'm going to go 8 minus 2, and then I'm going to have negative 4 minus negative 1. Okay, so what we end up with here is the double negatives. Okay, so we end up with negative 3 on bottom, and then we end up with positive 6 on top. So our slope is negative 2 for this line, so from a line segment. So from A to B we have a slope of negative 2. Alright, so then let's find the slope from A to C. Again, it's going to be y2 minus y1. So I'm going to use 8 minus 6, and then I'm going to have negative 4 minus 7. Okay, take the difference. 8 minus 6 gives us 2. Okay, I've got negative 4 and I'm subtracting from it, so it's going to make it more negative, so it's going to be 2 over 11. So our slope is negative 2 elevenths. And then finally, B to C. Alright, so I'm going to have 2 minus 6 over negative 1 minus 7. 2 minus 6 is going to be negative 4. I've got a negative 1 minus 7 is going to be negative 8. So double negative is going to make it positive. Reduce it, and we end up with 1/2. Alright, so we have the slope of BC is 1/2. Now, and this one's 2, negative 2, so if we multiplied those together, we'd end up with negative 1. And so that means that those two are perpendicular, and that's our right angle. So again, if I took negative 2 and multiplied it times 1/2, that gives us negative 1. So that means these two are perpendicular, which means this is a right triangle. Okay, with this one, we want to prove that this is a square. Now, so what that means is all the sides have to be the same length. So that's the first thing we're going to do, is find the distance between, or the lengths of each segment. So let's go length of AB. Now remember, our distance formula is the square root of x2 minus x1 squared plus the distance, the change in y, so it's y2 minus y1 squared. Alright, so for this one, A to B, so I'm going to go ahead and say negative 1 minus 1 squared plus y2, so I'm going to go 2 minus 5, square that, so I end up with negative 1 minus 1 is going to be 2, negative 2, we're going to square that, plus this is going to give us 3, so we square that, so we end up with 4 plus 9, or the square root of 13. So the length of AB is the square root of 13. Now, for this to be a square, all the other sides have to have the same length. So let's go to the length. Let's get on and work our way around. We'll go BC. Okay, so we're going to use the same formula. So I'm going to go negative 1 minus 4. Square it. Plus, let's go 5 minus 3. Squared. Alright, so we end up with 3 squared here plus 2 squared. Okay, so we end up with 9 plus 4, which is the square root of 13. So far so good. So those two lengths are the same. So now let's go length of CD. So let's go 4 minus 2. So again, I'm just subtracting the x values. So it's 4 minus 2, and then I'm going to subtract the y values, and then square them, and then add them together. So it's going to be 3 minus 0. So we end up with 2 squared plus 3 squared, which ends up being the square root of 13. So again, we're still in good shape. So we have to find the one last side. We're going to go from A to D. So the length of AD. Really should have put that, tell everybody what it is. So those just means it's a line segment. All right. So let's do the change. So let's go -1 minus 2. We're going to square it. That's going to end up being 3 again. But plus, okay, we're going to have 2 minus 0. And we're going to square. I need a little more room here. Alright, so we end up with 3 squared plus 2 squared, which is going to give us 9 plus 4, which again gives us a square root of 13. Okay, so for the lengths of the sides, we're good for a square with this. So all the lengths of the sides have to be the same. Now, that's not the only thing. They also have to intersect at right angles. So they have to be perpendicular to each other. So what we're going to do is find the slopes of the lines as well. So let's go ahead and find the slope of AB. Alright, so it's going to be y, change in y, so let's go 2 minus 5 over -1 minus 1. Okay, so I end up with 2 minus 5, which gives me 3. 1 minus 1, which gives me 2. Okay, it's going to be negative, so it's negative 3/2. Oh, excuse me, this is negative over negative, because that should have been negative as well, so that's going to be positive 3/2 for our slope. Alright, now let's find the slope. Now this right here, they have to be perpendicular. So what I'm going to do is go ahead and find this slope, and if this is not perpendicular to this, then we know it's not a square. So the slope AD. Okay, so we're going to end up with 2 minus 0 over -1 minus 2. Okay, so now we end up with 2 over negative 3/2. Well, we end up with 2 and negative over -3, or the whole thing's negative. So if these two are perpendicular because they're negative reciprocals of each other. If I flip this and change the sign, I get this. If you wanted to check, you can multiply these two together and you would end up with -1. But those two are perpendicular to each other. Now, so let's go ahead and find the slope of the other two lines. So let's go slope of BC. Okay, so slope BC, so it's going to be 5 minus 3. Okay, and then 1 minus 4. Okay, so we end up with 2 over -3. So it's parallel to this one, but it should be perpendicular to this one, which it is. Okay, and so then let's find our last slope, just to make sure. So we have the slope of CD. Okay, which slope of CD is going to be 4 minus 2 on bottom. Then on top we end up with 3 minus 2. No, I'm sorry, 3 minus 0. So we end up with 3 over 2. Okay, and so you'll notice that there's a pattern here. But anyway, these two lines are perpendicular to each other, and this line's parallel to it. So opposite sides have to be parallel. So just by looking at this, AB and CD have to be parallel to each other. So AB and CD are parallel. They have the same slope. Okay, so that checks out. And then AD and BC have to be parallel. They have the same slope. Okay, so that checks out. And then the ones that connect have to be perpendicular, which we showed. Okay, so opposite sides are perpendicular. Opposite sides are parallel, and then the ones that intersect so that they're perpendicular. So this is a square because, again, the distances are the same, opposite sides are parallel, and then the lines segments that intersect at right angles.